All right, welcome back. We're continuing on working with the GPIOs on the pies. We're going to connect two pies together and send some information back and forth. We're going to do that shortly as soon as we get a library figured out. I did find the correct reference for the GPIO for what we're working with here, the PigPieOC interface, before I ended up on the one that is actually for the daemon. We're going to use that in the future, but for now, we're going to continue working through these. We've already done the set mode, get mode. We've done initialize. We have to do a terminate as well, and I'm going to do that right now. Just set that up so that when this library here, when this goes out of scope, we'll have a destructor that calls GPIO terminate. But what we're going to do is do that in the C file. So we'll just go here and we'll go tilde GPIO, and we'll go ahead and put that in the CPP file right after the constructor. This is going to be GPIO : and what we'll do is go GPIO terminate. So that'll terminate the operation of the GPIO when this goes out of scope. So we'll go ahead and build that. Not that one. This one here. What's the problem here? GPIO tilde GPIO. What's wrong now? This is part of shared pointer. GPIO.h. GPIO.cpp. Build this. And do a build. Okay, it seems to be okay now. Build this. All right, I think it was just not building this before it was trying to build the console, which looks like it's the primary right now. So when I hit build down there, it's going to build this. It wasn't building the. That's a little strange. It should build dependencies first, but we'll try to execute this now. Make sure it works okay. Yeah. Sig handler on hand signal 2 terminating. Interesting. And of course, that's because I don't know why they doesn't load that into a console and keep it in the console. Console's briefly coming up, but very weird. is it should stay running because of this return a.exec. Should keep it running. Oh, because it's erroring out. That's why. Because it's got to be run from here. Actually, we can just run the .slant startup. Yeah. So that's just a test console to figure out if things are working, and we'll see that happening. So let's go continue on. Let's get our next one. Let me grab. Where is it? Let me get this. Not that. Let's close that and close that. Let's get this. So the next thing we want to do is we've done set mode, get mode. We want to do the pull up, pull down, and read and write. So let's take a look at what we have to do for pull up, setting pull up and pull down mode. So here it is. It's unsigned GPIO. That's the pin, and then the pull up or down code. So this is going to be pi, pud, up, down, or off. Clear any pull ups or pull downs. So we're going to again want our own definition of these. So let's grab that. Go here to the header file, and we'll call this enum class GPIO pull up down. We'll make it just up, comma, down, comma, off. So the nice thing about enum classes is they are in fact a namespace, unlike regular enums. Regular enum, all of these names would be global, and so off would be just defined in the one place, and that would be it. But with this, off and up and down and off are defined under this namespace. So let's come down here and go, let's take a look at that again. What does that require? It returns an int, so what it returns 0 if okay, otherwise bad GPIO or bad pull up, pull down, bad PUD. So we've got bad in our errors. We've got and we'll just call it bad PUD. We've already got bad GPIO, so we need to add bad PUD to that, and that means we have to go into our here, and we have to add those into the errors. So this is not we're not handling either of those, so we need to go case GPIO errors colon bad PUD return pi underscore bad PUD, and case GPIO, in this case here, I'm not going to worry about the unknown on that one. We're returning unknown here. Case pi bad PUD colon return GPIO errors colon bad PUD. There we go. We got that. So now we'll go back to our header file, and we want to have, again, let me pull this over and take a look, see if there's anything else we need to do. That's what it's going to return. And then we have to supply the translation of that which we've got, the up-down. We need the up-down translator. So we've got these up, down, and off. We could look at the values and translate them that way, but I prefer to translate them. So we'll go int translate up, translate pull up, down, and we'll go GPIO pull up, down, up, down. We'll grab this. We'll go over here to our CPP file, and this is our translate errors. We'll do this, rid of this, GPIO : translate pull up, down, switch up, down, case, GPIO pull up, down, : up, return pi pud up, case GPIO pull up, down, down, return pi pud down, case GPIO pull up, down, : off, return pi pud off. So there we go. And now we can come down here, go back to our header file, and we need GPIO errors, set pull up, down, unsigned int pin GPIO pull up, down, up, down. And we'll go back to our CPP file, and right after get mode down here, we'll put this in, this, unsigned, unsigned int, a little typo there. Let's go back to the header file and fix that. Int. And so now what we're going to do is return translate errors GPIO set pull up, down, translate pull up, down, up, down. Translate errors GPIO set pull up, down. Oops, it's supposed to be pin comma translate pull up, down, implicit conversion. Warning, implicit conversion changes signedness int to unsigned int. Oh, this should be unsigned int. Let's go to the header file. translate this. Yeah, this should be unsigned in. So it's kind of the same thing. There, that took care of that. Get mode, implicit conversion, get GPIO, get mode, translate mode, unsigned int. Implicit conversion. Sign as int to unsigned int to unsigned int. Get mode. GPIO get mode. What's that return? Translate mode. Unsigned int. So I think this should just be an int. Translate mode. This should just be an int. And that should have gotten rid of something down here. Yeah. Okay. Control may reach end of. Okay. Return pi. Bad. Minus 10, return minus 10,000 or something as an unknown. Enumeration value unknown, not handled. Case, yeah, we should fix that. We should handle all the cases. GPIO errors unknown colon return minus 10,000. Darn it. Unknown. So that takes care of that. It's end of a non-void function. Return GPIO modes input as a default. Now we'll make it output. If we didn't know what it was, that'll clear that. Okay, it looks like that clears up the warnings. Let's do a build on this and see if there are any warnings showing on the compile output. This one. Return pi input, return pi output, output non-void function, return pi up. It doesn't matter because I don't think it can ever reach that, but this will get rid of all warnings. Unused variable mode. Oh, okay. Well, I'm not worried about this. Q debug from mode. is it? GPIO modes. So what we should do here is have a way to translate our GPI, some of these things, into something printable. So that's probably the next thing that we should do. We'll start with modes, since we're using that over there, and we'll just create a plain old C++ function. There's no need for an object here, and so we need a header file though. We need string string. So we'll go standard string, we'll call it mode to string GPIO modes mode. And we'll go back to our CPP file up here at the top, right under the shared pointer, I guess. Put this, and we'll go switch mode case GPIO modes colon input return quote input. Output alt 1 0 1 2 3 4 5. Input, we'll change this to output alt 0 alt 1 2 3 4. Oh, I missed one. 5. So this will return output. This will return alt 0 alt 1 alt 2. Let's put a space in them. Alt 3 alt 4 alt 5 Why is it complaining on that one case? Input, oh, that's why I was short one. I skipped one. There we go. And now all the cases are covered and it shouldn't have any problem. Let's build it. And then let's go to main and we'll go mode to string mode. And it's, oh, you know why? I'll tell you why. We're in okay. We're using Qt. We probably should go ahead and use Qt's stuff. So we'll just turn it into a Q string instead of a standard string. And we'll go back here to the CPP file and we'll change this to Q string. We should have no problem with that. We'll build this. And that way we'll be compatible here. And there it is. So we'll build this one. And that looks good. We'll come here and we'll run it and we'll see that we should, yep, input. There we go. And if we set the mode to off, or no, there's no mode off. Input. If we set the mode to output, build this. That's output. So there we go. That's working. Let me check the time here. I know this stuff can be a bit slow going, can't it? We're at 25 minutes, so there we go. We're setting the input and output mode, the pull up and pull down mode, and the next thing in the next video, we're going to set up reading and writing, and we're going to set up to be able to create some various kinds of outputs, other kinds of outputs. And I'll show you what those are. We can set up frequency outputs and pulse width modulation and all kinds of stuff that we're going to do. I may, because you can see this code is pretty simple, it's really just pass-through code, I may go ahead and write those functions offline and then just present them to you, show them to you, and explain how they work. Leave a comment, let me know which you prefer me to do, especially with these simple functions. If you prefer me to just show you code, or if you want me to sit here and write it live for you. It's totally up to you. I'm happy to do it either way. So anyway, that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I'll see you in the next video. Thanks for watching.